Okay, guys. Lesson 6.7 continues talking about functions. Okay, so we're still talking about functions. We will still use that whole idea of Fogg and Goff, the function compositions. We'll use that when we get to the end of this lesson. But we're going to start off by talking about inverse relationships. Okay, when we talk about an inverse, notice up there it says a relation that pairs an element A of its domain to an element B of its range has an inverse relation that pairs B with A. The idea, when we want to talk about finding an inverse, if you have an X and a Y ordered pair, the inverse is flipping them. Okay, instead of XY, making it YX. That's how you find the inverse, and that's what's always true of inverses. So, for example, here, okay, we have this relation. The ordered pairs 1.2, 1, 2, 4, and 0, -8. In order to get the inverse, notice what happens. It's going to flip-flop. Okay, to get to the inverse, it's going to flip-flop. Instead of the ordered pair being 1.2, 1, it's instead 1, 1.2. Instead of 2, 4, it is 4, 2. Instead of 0, -8, it's -8, 0. One important thing to note here is when we talk about a function, we talk f of x, correct? When we talk about an inverse function, we tend to say f to the -1, honestly, I usually read it as f inverse, but it's written, it looks like f to the -1 power. Okay, and that's just how we notate that that's the inverse. Now, one of the things you have to be able to do is you have to be able to write an inverse. Easy peasy when given an ordered pair here. Given a chart. A, ask, what is the inverse of each relation? So you're given the chart, 0, -1, 2, 0, 3, 2, 4, 3. Thoughts on what my inverse is going to look like? It's that easy, guys. Come on. Yeah, flip-flop. What does 0, -1 become? -1, 0. And I'm just going to set up an XY chart here. What does 2, 0 become? 0, 2. What's 3, 2 become? 2, 3. And what's 4, 3 become? 3, 4. That's all there is to finding an inverse when provided a set of ordered pairs. What? When provided, yes. I mean, we have different levels of problems we're going to work here. We're starting with the basics, of course, right? Okay, so let's go ahead and do the second one, and then we'll come back because we'll have to talk about functions here in a moment. So can you guys do the same thing on B? They gave us some XY ordered pairs. I want the inverses. What's the inverse of 0, -5? -5, 0. Inverse of 1, -4? -4, 1. Inverse of 2, -3? -3, 2. Inverse of 2, -3? -3, 2. Okay. Easy peasy inverses. Now, C asks us to go back and look at those and state whether the inverse of the above tables are functions. So, it's been a while. What do you remember about how to know if these are functions? Okay, so if you're provided a list of ordered pairs, how do we know? Because it wants to know, state whether the inverse of the above tables are functions. How do we know? Do you remember something, Kendra?
Each x value only corresponds with one y value.
Okay. Each x value can only correspond with one y value. So if we look at A, -1. Are there any other -1s in use here? No, -1 only goes to 0. What about 0? It only goes to 2. What about 2? Only goes to 3, and 3 only goes to 4. Okay? The shortcut that we often look at is we try, at least to get us started, do any of the x values repeat? Do any of the x values repeat? No, if none of the x values repeat, it's guaranteed a function because each x value pairs with exactly one y value. And so up next to this problem, I'm going to write function, as in, yes, it is a function. My explanation, just so I can remember, is that each x value pairs with exactly one y value. Okay, so it's just kind of your, reminder of how we know if something's a function. Each x value pairs with exactly one y value. Okay, what about, looks like a C. I keep wanting to say C, but there's actually, what about B? Is that inverse a function? A little more questionable here. So, does negative 5 pair with one y value? Negative 5 only pairs with 0. What about negative 4? It only pairs with 1. What about negative 3? It pairs with 2 here. What about this negative 3? It also pairs with 2. Does that one x value pair with one y value? Okay, it's kind of a tricky one. It's tricky on purpose, okay? In this case, what do you notice about negative 3, 2, and negative 3, 2? They are the same point, okay? So this is this right here, it still is a function, okay? It's still a function because each x value pairs with one y value. So I'm going to write my same explanation from above, that it is a function, and same story, each x value pairs with exactly one y value. And for the start part, what I will say is the repeat pairs the same x with y. Okay, so if you want to know why, oh, my x repeated, well, the repeat pairs the same x value with the same y value. Well, hold your thought. I'm getting ready to do a what-if example that might answer your question, okay? Then ask your question if you still have it. So let's look at C here. Well, we're going to look at C. Okay, we've kind of already done C. It said, stay whether the inverse of the above tables or functions, and how do you know? We talked about that, right? Okay. To answer some of the questions in your heads right now. What if the XY chart looked like this? What if it was negative? What if that chart had read like that? Is that a function?
That or the inverse of that?
This right here.
Okay.
I just went ahead and wrote the inverse. So, yeah, is this a function? Why not? Yeah. This negative 3 of x goes with two different y values. So this right here is an example of something that is not a function. The key is the x value of -3 repeated, and as it repeated, it went to two different y values. So, I'm going to write this in words, that it is not a function. And again, I'm putting this so you have it when it comes, time to think about it. The x value of -3 is paired with two different y values. And those two different y values were 2 and 3. And that's your key, guys, okay? The x value of -3 was paired with two different y values, that of 2 and 3. Okay. Little basic introduction. Technically, that was all Algebra 1 review. That seemed familiar, yes? Okay. Definitely something you have to be reminded of. On Monday, hopefully, assuming we're here Monday, I will plan to pick up, finish the notes, get you all of your examples, and then that would make homework due Tuesday. If we have e-learning on Monday, I don't know my plan, so don't ask. Yes, Eli. Okay. Okay, guys. Enjoy your weekend. Maybe you'll get some snow to play in.
Hey, that'll be fun.